Now let's look at graphing parametric equations by plotting points. So we construct a table with 3 columns, a column for t, a column for x of t, because x is a function of t, and a column for y of t, because y is a function of t. That's the whole parametric equation thing. Evaluate x and y for the values of t over the intervals for which the functions are defined, and plot the resulting pairs x, y. So we're not plotting t, we plot x, y. So here we have sketch the graph of the parametric equations. Excuse me, x of t equals t squared plus 1, and y of t is 2 plus t. So we'll have a t column. We'll have an x of t column. And we'll have y of t column. So let's go like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and scroll this a little bit. 5. So our x of t is t squared plus 1, so -5 squared plus 1. Sorry about bouncing around so much. -5 squared is 25, plus 1 is 26. And then 2 plus t, so -5 plus 2 is -3. So it's going to be outside this graph. This line goes up to, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, maybe it was counted there. Then for the next one, again, this is x squared plus, no, t squared plus 1. Okay, -4 squared is 16. 16 plus 1 is 17. And then -4 plus 2 is -2. Again, outside the scope of this graph. -3 squared is, quantity squared is going to be 9, plus 1 is 10. That'll fit in the graph. -3 plus 1 is -1. -2 squared is 4, plus 1 is 5. -2 plus 2 is going to be 0. -1 squared is 1, plus 1 is 2. And then 2 plus -1 is just 1. And then 0 squared plus 1 is 1. 2 plus 0 is 2. 1 squared plus 1 is 2. 1 plus 2 is 3. 2 squared plus 1 is going to be 5. So we're seeing the repeat here. And then it's 2 squared plus 1. So then we have 2 plus 2 is 4. 3 squared plus 1 is not is 10. 2 plus 3 is 5. 4 squared plus 1 is 17. 2 plus 4 is 6. 5 squared plus 1 is 26. And then 2 plus 5 is 7. So what we're really going to be graphing are the values here, doing there and there. Because the others are going to be outside the graph. Okay, so we start off with -10 for x. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 for x corresponds to -1 for y, right there. 5 for x corresponds to 0 for y. 2 for x corresponds to 1 for y. 1 for x corresponds to 2 for y. Then 2 for x corresponds to 3 for y. Then we have 5 for x corresponds to 4 for y. And then we're back to 10 for x corresponds to 5 for y. So we have a nice parabola that opens up sideways, which the graph of this alone is the graph of something that's not a function, because of the vertical line test. But we're able to graph it from 2 functions. That was kind of fun. Example 2, we are going to construct a table of values for the given parametric equations and sketch the graph. Okay, so let's see here. I'm going to go with t x of t, y of t. So we'll do these in terms of go by pi over 6 is 0, then pi over 6, then pi over 3, then pi over 2, then 2 pi over 3, 3 pi over 4, not 3 pi, we're not doing the pi over 4, so we're doing 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi, if I can fit it down there. Okay, so cosine of 0 is 1, 2 times 1 is 2. Sine of 0 is 0. Cosine of pi over 6 is square root of 3 over 2. So 2 times that is square root of 3, which is like 1.73. And then sine of pi over 6 is 1/2, so 4 times that is 2. Now we'll do pi over 3. Cosine of pi over 3 is 1/2, so 2 times that is 1. Sine of pi over 3 is square root of 3 over 2, so 4 times that is 2 times the square root of 3. So we're looking at approximately, what would that be? 3.46, something like that. And then pi over 2, cosine of that's 0, sine of that's 1, so we get a 4 here. 2 pi over 3, we're going to get negative 1 because cosine of that's negative 1/2 times 2 is negative 1. The sine, we're going to get our 2 root 3 again. 3.46. This was approximately 1.73. 5 pi over 6, we're going to get ourselves that negative square root of 3, which is approximately negative 1.73. And we're going to get 2 for the sine, for the y part. It's sine of that, sorry, is 1/2. 4 times that's 2. For pi, cosine of that is 1, so we get 2 times 1 is 2. And sine of pi is 0. 7 pi over 6, this is where they're both going to be negative. We're going to have ourselves a negative square root of 3 again, which is approximately 1.73 negative. And we're going to get ourselves a negative 2 for the sine. 4 pi over 3 is going to be negative 1. And this would be a negative 2 root 3. So it's approximately negative 3.46. And then 3 pi over 2, we get 0 for the cosine part. The sine part is going to be negative 1 times 4 is negative 4. Now this last part, cosine is going to be positive, sine is going to be negative. For 5 pi over 3, cosine of 5 pi over 3 is it's going to be the 1/2. So 2 times that is 1. And then for sine, we're going to get our negative 2 root 3. That's 4 times sine of that, which is approximately negative 3.46. For 11 pi over 6, we are looking at just root 3 for this one. Square root of 3 is approximately 1.73. Sine of that is going to be negative 1/2, so 4 times that's negative 2. And then 2 pi, we're at 2 for the cosine and 0 for the sine. Okay, let's go ahead and graph and see what we get. We start off, and maybe I'll scale this a little differently. I will call this 1, call this 2. Negative 1, negative 2. 1, 2. Okay. Oh, we do have the 3.46. Oh, I just realized that. Let me rescale this. Sorry to waste your time like that. Okay, so we have negative, let's go with positive 1 on the positive side. Okay, go 1, 2, 3, and 4, because we'll go up to 4. Not really, not on the x part, but whatever. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Okay, now let's plot things. 2, 0. 1.73 and 2. These are not precise, by the way. The next one is 1 and then 3.46. Then 0 and 4. Then negative 1, 3.46. Hey, I'm instant symmetry. And then negative, that should be a negative there. I guess that's the whatever. Negative 1.73 corresponds to 2. And then we're to 2, 0. And then we're coming down here. Looks like it's going to be an ellipse. We have negative 1.73 corresponds to negative 2. Yeah, I'll go with that. And then we're at negative 1 corresponds to negative 3.46. So somewhere right about here. The negative, sorry, 0, negative 4. It's got this last quadrant. We have 1 corresponds to negative 3.46. And then we have 1.73 corresponds to negative 2. And there it is. Back to 2, 0. So we get this kind of a shape. Okay. That was fun. Boy, it's going to be a long video. I'm sorry about that. Next one, graph the parametric equations. X of t equals 5 cosine t and y equals 2 sine t. First construct the graph using data points generated from the parametric form, then graph the rectangular form of the equation. Compare the two graphs. Okay. Oh gosh, there's another one. Let me stop the video and I'll do this in 2 parts. That's going to make, yeah. I'll do example 3 in the next video because it's getting long.